Charge particle A is fixed at the base of a uniform slope of inclination alpha. Just see, look at the figure. This is the charged particle A, which is situated or fixed at the base of the inclined surface. Another charged particle B, it is shown in the figure. It is placed on the slope at an angular position beta measured from the line of the greatest slope. Just observe that the line joining A and B makes angle beta with that inclination plane, as we have shown in the figure. Now what we have to do is the coefficient of friction between the particle B, which is there, and the slope is mu. Mu is less than tan alpha. Find the minimum value of the angle beta for the particle to stay at equilibrium. So we, for the particle B, that is B is the particle, that particle may just slide down. So we need to investigate the condition that what should be the maximum value of beta for which the particle B stays in the equilibrium. So just what we do is we consider the particle B and what are the forces acting on particle B. Just let's observe. The first force, that is mg, that has been resolved into two components. So along the inclined surface, this will be nothing but mg sine alpha. The normal reaction is nothing but mg cos alpha. That's the normal reaction. And the third force, which you can very easily identify, is the force of repulsion that these two charges they exert on one another. This is F. Now try to understand the direction of F. This was the inclined surface, and this inclined surface is itself inclined at an angle alpha with the horizontal, and from there this makes an angle beta. Is it not? From there it makes an angle beta. Now these are the two forces. Just try to identify. This is the force of repulsion and this is the mg sine alpha. These two forces are in the same plane as that of the inclined surface. So these two will have some resultant. So what will happen? The particle will have the tendency to slip along this resultant. Then who will prevent? The friction will prevent. So now what we understand, that once the friction prevents, see all these forces, it is not mg sine alpha. Mg sine alpha is perpendicular to the surface. Try to understand that here mg cos alpha, sorry, this mg cos alpha, which is the normal reaction, is perpendicular to the plane. Then the three forces, three coplanar forces, one is mg sine alpha, another is F, which is the, we can say, repulsion, and the force of friction, which is mu times, and the maximum force of friction keeps the particle in equilibrium. It keeps the particle in equilibrium. So what can we do is, we can very easily understand that Lami's theorem may be of little help for us to solve this. So let us use Lami's theorem to solve this. So what are the forces? The forces are, one is repulsion forces, as you understood, F. Another is mg sine alpha. And the third one will be the force of friction, which is mu times the normal reaction. Now what are the values of this? Just see, this is beta they have given, is it not? And this mg sine alpha will be parallel to this line, which is along the inclined surface. So this mg sine alpha, which will be making angle beta with that particular line, is it not? So this F will be making angle beta, the line of F will be making angle beta with that mg sin alpha. And further, let me take this angle for the time being as theta. So what we can do is mg sin alpha divided by which angle should I take? The angle between f and mu into normal reaction, that is sin theta. And then the other force is the force of friction, which is equal to mu times mg cos alpha divided by which angle should I take? The angle which is in between the other two. So we have to take, just observe which angle we need to take. This is the angle between mg sin alpha and f, which is equal to 180 degree minus beta. Therefore, what we can do is we can take this sine 180 minus beta. So like this, and there is no need to write the third force. It is because we don't require that. See, mg gets cancelled. So what we have as sine alpha divided by sine theta is equal to, now it will be equal to mu cos alpha divided by sine beta. Is it not? So from there we can have sine beta is equal to mu cos alpha by sin alpha multiplied by sin theta. Now they are asking the maximum possible value of beta. So for beta to be maximum possible, for beta to be maximum possible, we have the sin theta to be maximum. And under this case, the maximum value of sin theta can be equal to 1. Therefore, let's check. We can write sin beta maximum will be equal to mu times cos alpha by sin alpha is equal to cot alpha, and sin theta maximum. And the value maximum, because theta is independent, beta is not independent. So as this maximum is equal to 1, so what can we have as beta maximum? As per this particular situation, beta maximum will be equal to sine inverse mu cot alpha. Beta will be sine inverse mu cot alpha. This will be the maximum possible value of beta in this particular case.